Bystronic is a leading global supplier of system solutions for the sheet metal industry. We provide laser cutting systems, bending systems, automation, software solutions, and comprehensive services. We offer worldwide presence and competence. We speak your language and understand your needs. We are here for you. We don't simply develop machines that cut or bend sheet metal. No, our customers need flexible systems for ever-changing order positions and batch sizes. Automation to achieve top productivity with integrated systems and the right software that cross-links everything. Bystronic stands for Swiss quality.
Good morning or good afternoon. Welcome to Bystronic here in Switzerland. In the next 60 minutes, we will show you the fantastic products from Bystronic about laser cutting and automation for laser cutting. My name is Thomas. I'm responsible globally for the key account management. My team and I, we take care about the big multinational customers like Case New Holland. With me today is Stefan. Stefan is team leader from product management for laser and laser automation. We also have here Yves, and he is our senior application engineer for laser cutting. Before we talk about the product, I would give you a few informations about the Bystronic group. Bystronic started the business here in Switzerland more than 35 years ago. From the beginning, we produced laser cutting machines. Meanwhile, more than 3,500 people work all over the world for company Bystronic. You can see in the middle our core competences. This is for sure 2D laser cutting. We also have products for tube cutting with laser or profiles. We have bending machines. Then, of course, for all these three processes, we have automation, like loading, unloading, bending robot, tool changer. Bystronic produces their own software to program these machines. And, of course, also very important is after-sales service, maintenance, spare parts, and so on. Globally, Bystronic has 10 production plants, and we have 30 sales and service subsidiaries in 30 different countries. So here you can see the black, the black dots are the production plants in US, in Europe, and in China. And the red dots are the sales and service subsidiaries. So nearby everywhere where Case New Holland has a plant, Bystronic has an own sales and service subsidiary. So before we go to the products, I will show you some pictures about the Bystronic Niederrheins.
Welcome to our digital factory tour. We will guide you through the entire processes of producing a laser cutting machine at Bystronic. We will begin with our sheet metal production. So here we see a bending cell, ByStar Fiber with loading, unloading. There is a expert and fiber machine with a big storage system. Of course, all the cutted and bended parts are being welded in-house. So we have invested a lot in the last years in full automatic welding robots. As you can see here, welding a Bystronic frame. Then of course, all the parts that we are welding in-house, they have to be milled. So that's why we have here those big milling machines. As you can see as well, here is an entire machine frame in the machine. We're machining them here. The left-hand side, we have the Unisign machine that is nearly as big as the Mega Mill. Here ahead of us, we have a machine that is more used for milling smaller parts. As you can see, we have here those towers. That's where we put all our parts in. And our ERP system will automatically choose the parts that are needed on the correct timing. The machine will process them and bring them outside. So let's move to hole number 2. Hole number 2, it's our storage and R&D. So here on the left-hand side, we have a storage system for small parts. Straight ahead of us, a big storage system for large parts. And the entire basement of this building is storage for big parts. Of course, we have as well an in-house paint shop. So the parts are first being washed and then being painted. So here you can see small parts, we hang them to paint them. But of course, we do as well the paint job on the big parts, like here again a machine frame, and here a cutting bridge. So let's move to hole number 3. In hole number 3, that's where we do the final assembly of the single individual parts. So we'll straight away begin in a basement. Here we have one of the most important rooms, our clean room. Of course, we cannot enter the clean room, we can just pass in front. That's where we assemble all our cutting heads, sources, do some splicings and stuff like this. So that's a very important room of our factories. Here we have the pre-assembly of our cutting bridges. So as you will see here, we are working in steps. So on the ceiling it's written the different steps. So the bridge is moving from one step to another step. And in each step we have all the parts that are used or are being used for that certain step, for that certain bridge. So after the bridge is finished and tested, we go on the ground floor and we assemble the entire machine. So we have 2 lines. We are starting here with the big line. So big line means 4-meter and larger machines. So as well, those machines are moving step by step in front with the parts that are always on the specific spot that we need them. Of course, once the machine is tested, we have cut it and everything, we load it here on the back inside of a container or directly on the truck. So on this right-hand side here, we have the line for the small machines, quite empty at the moment. Sometimes we have to empty it if we have to make some changes or whatever. So that's the case right now. And now we will transit to our office building. So that's the back entrance of our office entrance. And here on the right hand side, we have plenty of meeting rooms. So one day I hope to welcome you here at our entrance and to accompany you in our meeting rooms, to have a coffee together. And then of course, I'm more than happy to see you in our customer center.
Ladies and gentlemen, welcome back from the company tour. I'm as a product manager, I would like to show you how Bystronic sees the market requirement and what are our answer to those requirements. In order to make sure that our customer, you, are competitive and earn money, we have recognized 5 market requirements. First of all, I would like to start with power and productivity. Everybody's talking about power, and speed. Of course, it's quite important, but not everything. Bystronic goes also the race with power, but we have much more we can deliver than just power. For example, cutting quality. It's also very essential to be able to provide best cutting performance for each part in different kind of materials. For that, we need perfect parameters, the right cutting technology, and of course, the right cutting gas. That means we also offer nitrogen generator. With this, you are independent from any gas supplier. You produce what you need. We have a gas mixer to offer, and you also can cut with our fiber laser machine with oxygen cutting gas. Another big topic is flexibility. We have quite a lot of customers that do not know what they will cut tomorrow, and so they want to have the full flexibility to be able to cut from very thin to thick, or from mild steel to copper, brass, aluminum, and so on. And our product range covers all this kind of needs. Autonomy, it's an increasing requirement, and for that we have, of course, automation. That's part of autonomy, but it's not everything. Autonomy means for us to ease the life of the operator, to make sure the operator can start the production process very fast. Means he has some supporting features, as you also have an option in our offering. And last but not least, as a technology driver, we also focus very heavily on artificial intelligence. What does it mean, artificial intelligence? Just to produce very fast on a short time, that's not a challenge. You have to maintain this performance over a long time. So you have to maintain, monitor the process, and if something occurs, take the right action and correct it without any operator interaction. Having said this, all these kind of features are part either of laser cutting machines or automation. And for that, I would like to show you now what we have in our offering, starting with laser cutting. Here on the left side, you see actually our benchmarked machine, set a benchmark in terms of productivity, called ByStar Fiber. This machine is available from 3 to 8 meters and up to 20 kilowatt laser power. Big benefit, of course, as already mentioned, high power readiness, high dynamic with linear drives, good accessibilities with the sliding door from the side. You have the full access to the entire sheet. And of course, most important is simplicity. How fast you get from the file to the final part. And there we have a benchmarked programming software where you can program offline called BySoft. And with this BySoft, you program, send to the machine, and then with just a few finger swipes, easy to operate like a smartphone, you can operate the machine. And with this we call precision cutting. And don't forget, all the features I have mentioned in the beginning are part of the ByStar Fiber as an option available. On the other hand, we have the silver line, from 3 to 6 meter machine size and up to 10 kilowatt laser power today. But very soon we will have it up to 12 kilowatt as well. Also here we have the unique programming software, BySoft, and the precision cutting operating system on the machine. A difference to the gold machine is we have some features, of course, to support the operator in fast set up the machine or process monitoring, but we don't have all the features available on the Silverline machine. All these machines are combinable with a wide range of automation solutions. Here we see actually a different kind of load and unload solution we offer to our customers. But what is the right automation for you? That's very much depending what is the workload you have, how much material you want to process, how much space you have in your facility, is data flow for raw material, remnant parts or cutter parts required or not. Here we see actually a selection of 30-15 and 40-20 load and unload solutions. Of course, in the lower left corner you see also for bigger formats we have automation solutions, but it's not part of the standard product line. This load unload is capable to handle mild steel thickness up to 25 millimeter, except the by sort. It's just possible to sort up to 15 millimeter mild steel. This load unload, either you have it as standalone, just connected to a laser cutting machine, or you can have it also connected to a storage system. You see here different kind of storage systems, single tower, multiple tower, cross line, whatever you need. And it's a standard offering. We have tower height up to 7.5 meter with maximum 31 location for cassettes. What means locations? Cassettes for loading cassette and unloading cassette. That's the space available for those different kind of cassettes. Per default, for a 30-15, the maximum load of a cassette is 3 tons, and for a 40-20 is up to 5 tons. Last but not least, we have the most compact loading, unloading and storage system called ByTower Compact. This ByTower Compact is available up to 8 meter and has locations up to 21. That means you can choose how many load and unloading cassettes you prefer, but maximum space is for 21 cassettes. So, we have heard quite a lot from the market requirements. Then I gave you a brief overview on the laser cutting portfolio and now on the automation portfolio. But seeing is believing, and that's why let's have a look, go to Yves, and he will take you to the demo center and show you in reality what you're able to do.
So welcome back at the BySmart Fiber 10 kilowatt. So this machine is available in 3 meters and 4 meters from 2 kilowatt up to 10 kilowatt. Let's have a look. We have the opening from the short side on this machine. Here inside we have an aluminum cask bridge with a gantry system, which means we have left and right a motor with a rack and pinion, which is moving our axe front and back. We have a rack and pinion motor for the Y-axe, and for the Z-axe we have a spindle. Here on the left hand side we have our nozzle changer with 40 different nozzles. And here on the right hand side we have our automatic nozzle recentering station, which means so if you have a collision here on a cutting head or something is hitting whatever, the machine will realize, go and recenter and continue to cut. Here we have the brushes to clean our nozzle. This machine of course is equipped with the latest generation of Bystronic cutting head. We will go into this kind of details like cutting head, feeding fiber, laser source, all the features. We will look deeply into that when we move over to the ByStar Fiber. For now, we will cut here 3 millimeter mild steel with 10 kilowatts, so we can really see high-speed cutting on this machine. So it's now cutting with full laser power, 10 kilowatts. So here we have 27 meters per minute on a straight line cut. That's what we see now. That's really the speed. That's extremely super fast for 3 millimeters. Let's have a look at this part. So, perfect part, perfect edge quality, no burrs on the bottom, but it's not just about having a very fast part. It's much more important to have reliable and stable process. So it's very important that we cut not one part very fast, but that we can cut 24/7 perfectly. So now, of course, in 3 millimeter, we see the speed of 10 kilowatts, but that's not really where we have the sweet spot of that. So for explaining this, we made a nice video that is comparing 3, 6, and 10 kilowatts. Let's have a look at that video. So in this comparison, we're comparing 10 millimeter mild steel. So you can see left 10 kilowatt, in the middle the 6K, and right 3 kilowatts. So already now you see a huge difference between the 3 laser powers. And that's what it counts actually. It counts when we are cutting on a part, not just comparing the feed rates. That's not really relevant, the feed rate itself. The most important is the time for the part itself. So 10 kilowatt at 37 seconds. Six kilowatt is soon coming to an end. Not the double of the time, but quite slower. So now we are speeding up a little bit for the 3K. So you see quite longer on the 3K than on a 6K, and especially a 10K. Now here we see the productivity, because that's what counts at the end. So how much more do we produce on a 10 versus a 6 or a 3K? So now we will go to the ByStar Fiber. It will take us a quick time to transfer all our equipment over there. So meanwhile, we will show you a short introduction video about the ByStar Fiber. So let's see, the big advantage of this machine is the long side opening. So we can open the door the full length. Here we have a very special bridge profile. As you can see, it's a triangle. It's about 40% lighter than a standard profile and about 60% stronger. Here on the back side, we have an additional door that you can have. That's an option. It's quite a nice option if you have a rotary axe. So let's walk around the machine. The human interface we'll have a look at the very end of our session. Here we see that box. That box is in case if you have a rotary axe, to put your tubes inside, to support them, to hold them on the correct height. So here on the behind of the machine, inside this electric cabinet, which you could put as well this entire cabinet here on top of the machine or somewhere else, that's no problem. So here we have our 15K laser source. So this is a real fiber laser with an efficiency about 45%. And here we have the cooling unit. There's just a little bit of water inside, about 50 liters, not more. So no chemistry, just simple water. Let's have a look here on the back side. Here is our electrical cabinet. So that's our CNC. That's the most important part of the machine, of course. That's completely Bystronic. So this is actually just a PC. This is a high-end PC, and the CNC is actually just the software, just a USB stick. So the advantage is we can update it whenever there's a new version. You take the advantage of the entire new features. Here we have the servos. Of course, on this machine we have a forced servo because we have a rotary axe for the tube. So let me close this. So on the back side here of the machine, we have here our cross conveyor. So this machine is equipped with a conveyor bringing all the trash all the way of the machine. Then with the cross conveyor out in a bin like this, you can choose to have it on this side of the machine or the other side of the machine. So this always comes in a set, the longitudinal and cross conveyor. So let's go back in front of the machine. Let me quickly go into the difference of a CO2 and a fiber laser. So on a CO2 laser, we typically have this dischargement tubes. So we have a gas flow here. To make that gas flow, we need a turbine. The turbine has a certain lifetime, needs to be replaced after a certain time. Those glass tubes, of course, as well will need some replacement because we are putting 20,000 volts between those 2 points and have a dischargement here inside. So they start to get dirty and they need replacement. Of course, because of the high voltage, we need a lot of electricity. The beam is then continuing being deflected by copper mirrors. Of course, those as well need maintenance or replacement. The biggest problem though is on a CO2 is that we have not always a constant beam. Depending where we are on the table, we have different conditions. And as well, before and after service, we won't have the same conditions. On the fiber lasers, things are slightly different. Let's have a look at this. If that's a glass fiber, of course, much enlarged now, we have here ytterbium particles inside. Ytterbium is a solid state material, like a stone, a rock, a piece of metal. So all those parts are put inside that glass fiber. That is somehow replacing the gas on a CO2. The fiber itself is somehow replacing the dischargement tubes. So now what is happening? We have an LED, let's say, that is lighting inside that fiber. That light of that LED is hitting an ytterbium, and at that moment we set free the light that we use for cutting. So those diodes, they don't have a wear, the fiber doesn't have a wear, and the particles do not have a wear. Of course, they can break their electronic components like the diodes. So that would be some diodes. It's a bit difficult to see, maybe that's all small diodes. So they would light through a small fiber inside the active fiber. Typically with one active fiber we make 2000 watts, so not enough for an entire machine of 20 kilowatts. So we will add them together. So what happens, this one in a normal size is 0.1 millimeter. So we add all of them, and then we have our transport fiber going to our cutting head. That's a transport fiber with the quartz in front that we enter into the cutting head, and here we see our fiber that we use to transport the entire light. This fiber here is pure glass, so there is no ytterbium inside of this. And of course, the big advantage, as I said just before, is the high efficiency of this system. Another very important part of the laser machine is the cutting head. This is our cutting head. This is nowadays really a key feature of the entire machine. That's the most important part. I will quickly explain to you as well on the whiteboard how it works, just that you have a little bit of an idea. Once we are exiting that yellow fiber, the beam is expanding like this way. Here we have a mirror to deflect the beam downwards. Here we have our lens that is putting our beam to one single small spot. Underneath, here we have two protective glasses. Here we have the nozzle tip for the gas to flow out. So this protective glass here is sealing off the entire upper part from any dirt. And this protective glass is the wear part that you change all the time. So this, you replace it, this can just be replaced from Bystronic, so you're avoiding that you're risking to damaging your lens. So, if here we have some material, sometimes you want to move this point up and down. For this, we will move up and down this lens. In case if you move this lens up here about 1 centimeter, our focal point is about 10 centimeters more down. So you see that's a clear problem because the material remains here. So what we have to do, we have to shift that entire part of the cutting head 10 centimeters up to bring the focal point here. This we do it actually with a mechanical part that is holding the cutting head, and we use the motor of the Z-axis. So to explain this a little bit more clear to you, maybe on the back here we can see that the metallic fork which will hold the cutting head here. Yeah, exactly this part. Now I will show you, it will be holding here this part. We see that part here is completely up out, that will go down. We will quickly show you now a little video to explain that much better. So here in this video we can see that that fork now is holding the cutting head, and the Z-axis tearing the cutting head into two parts, let's say, to make it longer. Actually, I just realized I forgot to explain you why we do this. I will go back afterwards to the white board to explain it again. As well, here we see the changing of the nozzle, the full automatic nozzle. We have here 64 nozzles in that nozzle changer. So I quickly cleaned the board. I told you I forgot to explain you why we do this. So the first position, we had an angle here like that, and when the lens is completely up, we have a complete different angle. That reminds us on all times on a 5-inch and 7.5 inch on a CO2 laser. So, which makes it for thin material and for thick material. With this cutting head, you can change this in 7 positions. So, that's the reason why we do this. But actually the most important is the machine does everything by itself. So we really say, okay, we cut this material, the machine will choose the nozzle, we change the focal length, we'll do the centering and everything automatically. Before I told to you about the protective glass. So I want to show you how easy that's it. So we just open here that small cover. Here inside we have our protective glass. So you always get 2 of those cartridges. Then you just replace the glass inside, obviously. And of course, the upper and the lower protective glass both are monitored, so the machine will tell you when they're dirty, when you have to replace them, and so on. So that's completely secure. So here on the bottom, we have our nozzle body. I take one here. So the nozzles are just plug and play, so we do not have a thread here. So they are just like, you just put them in and you take them out, very easy, no problem. So in case if we have a collision, this entire bottom part can move in all directions. Of course, the machine will realize it, will automatically recenter, check if everything is okay, change the nozzle and restart the cut. In case if we have a really bad collision, we have here that small fuse. So this will break. We just need to replace this. And of course, the machine as well will realize if this part is broken and we need to replace it. So as well, to show you how this is working in combination with our nozzle control tool. When we see here on the back, we have there that hole, that inside there is the nozzle control tool. So I have a small video to show you, to explain you how things are working. This video is in combination with our option that is called Curve Scan, which is a system to control the cut while cutting in oxygen. So we have the cut control for the diffusion cutting, and for the oxygen cutting we have the Curve Scan. That's with the nozzle control tool together, that option. We will see the video now to explain this easy to you. So here we are cutting some mild steel with oxygen. As you can see, after the cut we go back and control this. We don't do this all the time, just on certain parts at the beginning of the car, obviously more than at the end. So here we can see the cut is perfect. When we go back to control it, still everything is perfect. So here some slag is occurring on the bottom. We can see the cut is not anymore perfect. So when we go back, we will realize that. So that's now our nozzle control tool. We are trying to figure out why we had a problem. So we check the nozzle, we check the centering. The centering was not okay, so now we're recentered. We go and change the nozzle, obviously, and we'll continue to cut. So with this system, we are adding, depending the thickness of the material, between 2 and 5% of cutting time. So not that much. But like this, you have a secure process and you're not producing trash. So now everything is perfect, and we continue with our presentation on the machine. So while I was explaining to you the videos, we as well quickly prepare the machine. So now here we have 1 millimeter material, mild steel on the machine. As well, we already loaded here our cutting plan. That's what we will cut here with some scannings. Here we have small holes, scrap destruction. So this part is actually really to show you the dynamic of the machine, the speed of the machine. So we will start that plan. We will switch to the cameras inside the machine to show you the cutting, and then we'll come out of the machine again to see the part.
So let's move to our starting point. And let's start the cutting. So here we are cutting about 74 meters per minute. So it's quite fast, but we don't see the advantage of a 15 kilowatt on this cutting part, obviously. It doesn't make sense to have 15 kilowatts for that. But I just want to show you this part to show you the dynamic of the machine so that you can see the speed and everything. So here we see a lot of scrap destruction. What you see right now, that's scanning, we call that. So this is a mode where we are cutting all the skull squares in a line, so we can save time, obviously, but as well we can avoid collisions. I will show you afterwards on the camera this small scanning that we just cut before. It was like 1 millimeter branches, so there is like no material left. So now we are coming to the end. So let's see what is happening to that part. Let's see the quality of the part. So I'll take out the part, put it in front of the camera so that you can see it. So here, perfect cut. Here you saw the small branches. That's what I said before. On the other hand, all the small holes. Let's see upside down. Same quality on both sides, perfect part. First, I have a little video that I would like to show you, which we have made a comparison of stainless steel 10 millimeter material on 3 different machines. We will first see that.
So that was stainless steel. Now let's talk about mild steel. Since quite a while we are cutting mild steel with mixed gas. Mixed gas means we take a huge amount of nitrogen, small amount of oxygen to cut our mild steel. The advantages of mixed gas is that we are a little bit faster than with nitrogen. Nitrogen obviously is a lot faster than oxygen. A bigger advantage even in the speed is that we are able to cut in a good quality, low quality material. So the surface is much less dependent. So when you have rust on your surface, color, pre-coating, whatever, we can still achieve a very nice edge and a little burr. So that's a big advantage of the mixed gas cutting. Of course, on mixed gas cutting, you're using a lot of nitrogen like on nitrogen cutting. That's a disadvantage compared to the oxygen cutting. But if you get yourself a nitrogen generator, solar panels on your roof, you're completely independent, and most probably you have the cheapest production possible. Let's start with a comparison in 20 millimeter mild steel, mixed gas. Let's have a look. So now that we saw the big advantage in 20 millimeter, I want to show you as well a part. To see how the part looks, you will see the edge is black. That's a different. With the nitrogen, we have a white edge, so it's black, but it's not like the oxygen cutting. This is no problem for painting and as well no problem for welding. If you look at the burr, it's quite little. We have very clean edge. If we go to 25 millimeter, 20 kilowatt, perfect edge, very, very little burr. I believe quite often you could just sell the part and use the part as it is here, but more than double the speed than oxygen. That's a sandblasted part. If we have a look here at the edges, the small edges, fantastic. They're quite tricky, no burr. Other sandblasted part, very little burr. Of course, the small contours, that's what I said, with oxygen, this will give a problem after a certain number of parts due to the heat impact. With nitrogen, mixed gas, no problem. As well, pre-coated materials, high strength materials, perfect edge, nearly no burr, fantastic results. So far, we just have been talking about fusion cutting. Of course, we have been working as well on oxygen cutting the last years. So we have developed a new process that is called OHC. OHC is combination with the beam shaper. I'm not going to go into details about the beam shaper right now. The beam shaper is just a lens, so we would remove the protective glass out of the cutting head, add inside a new cassette that is a combination of the protective lens and the beam shaper. So we would add that, and the OHC, as the name calls it, oxygen high power cutting, means we're using the full power to cut, up to 12 kilowatt. In the past, the maximum power we used for oxygen cutting was 6 kilowatt. So with more power, we reach a higher speed, which can be quite interesting in certain materials, in certain thicknesses. I would like to go through a few charts and videos with you to give you a bit more insights about that subject.
So now on the screen, we can see actually the difference in feed rate if we use 10 and 12 kilowatt is on the bottom line with standard parameters, and then if we use the OHC, so more powers, we see quite an increase with 10 kilowatt already, with 12 kilowatt even more. It's quite a big difference if you think on sheets that might go 1-2 hours on cutting or even more. Here we can see on the piercing time, it's going to be quite a big improvement as well. On the top, we have 100% our standard piercing times, which are on 12 and 10 kilowatt the same. With OHC, you can see it's a lot faster. We have as well a video which we want to show you for this. Okay. So here we have, I decided to show you a video instead of cutting it into live because it's a much nicer comparison that we have done here, those two parts next to each other. So on the left-hand side, you see the OHC full power. As I said before, maximum 12 kilowatt right now. So as well here, or in this case, not much gain to have a 15 kilowatt, except of having a little bit reserve. So now we are speeding a little bit forward to save time. So on the right-hand side, it's written 6 kilowatt. That's because on the standard procedure, normally we just use up to 6 kilowatt and not more power in oxygen cutting.
I want to quickly explain to you our ByVision cutting, our human interface, how that's working, what's doing. After that, we will switch back to the automation here on the back, the ByTrans Extended. ByVision cutting, our human interface. Let me give you a short introduction into that software. So we have here different tabs. First tab is for job preparation, second tab for cutting, and third tab for the automation. Let's start with the job preparation. So here we have our job list from left to the right, so that's the actual position. Next job, and this job actually has a stop, so which means the machine will cut until here and then stop. I can just drag and drop my jobs as I want, so I can change the order of the cutting. I can change as well the nesting, so in this job let me edit that job. Here we have a full sheet. Let me change that full sheet to an L shape, for instance. So now the sheet changed to an L shape. I can take that part, drag it down here, make an automatic nesting, choose until where. I'm happy with that. I can add parts from my parts pool or other jobs. So let me just take in that part here perfectly. I can add skeleton cuts, that's quite a nice function. And I can cut off the skeleton cuts I don't want. So like this, we cut them off. Let's go back. Yes, we want to save that job. So here we can see my job has been changed and is ready to cut. Let's move to the cutting tab. So that's our cutting plan that we're cutting right now in different colors, the different cutting technologies, which means if I want to change my cutting parameter while cutting, I just click on the correct contour. So that's large contour, that's engraving, that's the piercing. So I don't need to think where to change. I just click on the contour and I reach the correct position. Quite easy. Of course, we have plenty of functions and restart functions that we can change as well while cutting, so everything is really dynamic. But I'm not going to go into details here. I want to quickly show you as well the loading, unloading. So here we have the top part from the Bytrans extended, that we have raw material. Here we have a cassette for big part removal, and on the bottom for the skeletons and the remaining parts removal. So that was it from Byvision Cutting. So, we're back again on our Bytrans extended and our Bytower on the back. As I mentioned before in the software, here we have the 3 cassettes. I will quickly show that to you. Meanwhile, we cleaned the table and we started the process in full automatic. So the machine is already cutting. So what we will see now is our Bytrans extended will go and catch cutted parts, put them in the big part removal cassette in the middle, and we'll put the remaining on the bottom. So one second sheet is already loaded, is entering the machine. So the advantage of this system here is that we can load everything with the wooden pallets. So we are not limited or we do not have to unload each material to put it into cassettes. As you will see now on the back as well, you can see on some cassettes we have it with the wood. So here now the unloading part. So the Bytrans extended can actually handle between 1 millimeter and 25 millimeter. So here, before we are removing this part, so that's cutted parts here, huh? You see? So before we can remove the cutted parts, we have to adjust those vacuum cups. That's what I'm doing. I'm checking if all of those vacuum cups match here on a certain part. Otherwise, I can just shift them like that. That is all okay. So I quickly had to confirm the light barrier. Now, as we can see here, we are picking up the parts, lifting up. So we decided to remove just one part. The other parts are remaining and they will go down with the skeleton. So we see now here the middle cassette entering, dropping the parts on the middle cassette. The changing table moved here behind where we have the twin fork system to unload the skeleton plus those parts. So very important, everything is working in full simultaneous action. So unloading, loading cycle is less than a minute. Here we are less than 2 minutes because of because we are using, of course, more time to put the big parts on top. So on the bottom we can see we are unloading the skeleton and the residual parts. The table now is empty, and the loading system is taking the next sheet already to load the table. So we are measuring, as you can see, the thickness to make sure we took just one single material sheet. So now the machine is loading the next sheet. Here we can see that top cassette, what I told you about the raw material. Then second cassette here where we can see our cut parts inside. And on the bottom we have, with the tower, we have a residual cassette. And here we have added a tower on the back. This is, I would say, most probably the fastest and most efficient way to add a bit of automation. So we have as well, of course, other systems. So we are going to go into that. So we'll start first with our ByTower Compact, which is situated on top of the changing table to make everything a little bit more put together, so the footprint is becoming smaller. So the ByTower Compact is on top of the changing table. Like this, we have a quite smaller footprint. We can have this ByTower Compact in 3 meter by 1.5 meter or 4 meter by 2 meter. And we can choose the option to load the material with the wooden pallets or without. Of course, that plays an influence on the numbers of cassettes. Without wood, we can go up to 16 cassettes. So, our ByTrans modular is a really flexible loading and unloading system. So it can be attached to any kind of storage system from plenty of different brands, obviously, and it's fitting all our machines. So here we see actually a loading of a raw material. This is happening with vacuum caps. We pick up the sheet and bring it on a table, exactly like the ByTrans Extended did. The machine at the moment is cutting some material, so we'll soon change the table and do a sorting. So as well, this system here is working until 25 millimeter full sheet sizes, is available in 3 meters, 4 meters length. And of course, as well, in this system here, we try to make as many moves as possible at the same time to be the fastest possible. So our BySort is now taking away the parts from the table, the cutted parts. So we're using both arms to take 2 parts at the same time, or we're taking both arms together to take a large part. Now we are changing some tools. Of course, we have different tools. Most of them are with vacuum, could be as well with magnetic. So that's what we see now. We are taking with both arms together 1 part. Like this, we can lift parts up to 100 kilos. Each arm 50 kilos. And we have a cycle time of about 10 seconds for unloading 2 parts, which means 5 seconds per part. Of course, we see now we were unloading parts first on the station for the AGV on the front, then on normal pallets. Now we are unloading our parts on the cassette, so the parts, they go now with that cassette back in our storage system, from where we can take it whenever we use it, or it goes to a second operation. In this case here, it will continue to a bending cell, where we will bend the parts and then bring it to the welding cell. That's our twin fork system removing the residual sheet. And actually this entire system here is our smart factory. We will shortly after this see a video about our smart factory. And then we will see a video about our smart factory software. I will let you peacefully watch those 2 videos, and after that we will see each other for a question and answer session in front here of a machine again, back in Netherlands, and see you later.
Today's sheet metal industry finds itself in a dynamic market that demands new and flexible answers. Quotations must be sent in shorter times, orders must be delivered faster. New challenges arise every day. At Bystronic, we have been listening to the wishes of our customers of different company sizes and digitalization stages. The Smart Factory software is a modular and scalable cloud solution which integrates software from different providers and manufacturers and can be implemented in any existing environment, from job shops up to large factories. At the machine level, the shop floor cell control controls and reads out data from a cell. An open and collaborative solution enables the integration of machines from different manufacturers, thus creating a standardized data structure. A powerful CAM system helps to import or design the sheet metal products, optimize the layout and produce the jobs for each one of the manufacturing cells. The implementation of a possible storage system and computer-aided production is carried out at the factory level in the sheet metal business system. The sheet metal business system is a compendium of business applications which can handle critical processes such as scheduling, quoting, data analytics, sales processes, inventory management, or raw material procurement. This cloud-based solution will be available through the Microsoft App Store and will be easy to install and update. Bystronic offers you support in assessing your digital maturity level and helps you set up the best strategy for success in the Industry 4.0.
So now you have a good overview about Bystronic Group, our global setup. We gave you a good overview about our production here in Switzerland for laser cutting machines, and we showed you our solutions for laser cutting and automation for laser cutting. And as you have seen, we have from single standard machines up to smart factory, and everything in between is possible. So now, questions. Please write your questions in the chat and we will answer it. So one question is maybe to you, Yves. What is the maximum flow of nitrogen that the generator can supply? And what is the purity?
So that depends a little bit on the generator that we choose. So we have different generators as well, different producers or partners, let's put it that way, depending if Europe or US. The generator that we are having here in our demo center has a purity of 6.0. Other ones are 5.0. Anyway, you don't need to have more than 5.0 purity. That's more than enough. The generator that we are using here in the demo center has 160 cubics per hour. And that's enough to supply actually 2 machines. But of course, there is as well bigger ones that could supply more than 2 machines, because we would produce the nitrogen, put it into bundles, and then from the bundle go to the machines. Of course, it really makes sense to put the entire thing together with photovoltaics.
Mm-hmm. Good. Then next question, maybe Stefan. Does the Bystronic have some kind of software or module to measure, control automatically the OEE for laser cutting machines?
At the moment, we are working heavily on the new software structure, yes, but actually at the moment we are not able to provide a fully fledged and working software which monitors the overall equipment efficiency. This actually at the moment is not ready, but yes, we are working on new software structure.
Good, thank you. So no more questions. Yeah, then I would say that's it for today. Many thanks for your time, for your interest, and don't forget, Friday this week, same time, same place, we will show you our solution for bending and automation for bending. Wish you a good day. Bye.
Thank you very much for watching.
But weißt du was?
Sorry, we are back. I've seen there's one more question. Can you are cutting similar to ByStar, or will it be more operator intervention adjusted? Actually, the cutting head is today it's the same cutting head for standard power up to 15 kilowatt on the ByStar. For higher power on the ByStar 20 kilowatt, you have a different kind of cutting head. And very soon we will also have new features, which is available just on the ByStar Fiber, not on the BySmart. So actually 95% is similar, but depending on technology, monitoring features and power, they are slightly different. We give you a little bit more time. Maybe there's some time delay for other questions. Sorry about that.
No, I think that's it.
Seems to be everything very clear. So, yes, then again, thank you very much. If you have any questions, just reach out to us. We are more than happy to answer all your questions. Thank you and have a nice day.
Have a good day. Bye.